Now, if you're really adventurous, you can make a 3-corner reflector. So, now did you make this, or did the shop guys make this?
I cut the mirrors, and the shop guys.
Yeah, the shop guys just built a corner, a literal corner. Yeah, use the flash. You're going to get it all. I'll talk about that in a second. But if you get one of these, like Keith said, cutting the mirrors are easy. And if you know someone in the shop department, this was probably 10 minutes for them.
Oh yeah.
Yeah, I mean, really, just out of scrap wood, it was very easy for them to make. And then you've got a true corner reflector here. And if we go to the back, who's in the back there, green vest? Chris?
Yeah.
Okay, you ready for a demo?
I don't know.
So just stand up. All you have to do is point the mirrors towards the front of the room, and that's where I'll be. And have a student get in the back and just, I usually say, Chris came in for extra credit yesterday and she worked on this demo. Remember when you just held the mirrors like that right towards me? And you don't want to look there, you want to look, can you tip the top down a little bit? Remember, yeah, how you do that? And is the laser coming right back to me? Okay, remember how you tipped it over to your right a little bit? Yeah, and it coming back to me? Oh yeah, right in my eye. Okay. And remember how you tipped it that way a little bit? Yeah, and is it still coming right back to me? Yeah, remember how you tipped the top down even more? Uh-huh. Still coming back to me? So no matter what, no matter how she holds it, you can't get the demo wrong. Because as the lasers reflect, yeah. So good. So the laser will always come right back, just due to the geometry. Perfect.
So then after we show them the big one, we talk about some practical applications of those corner reflectors. And I'll ask the students, hey, why would you ever want light to come right back at you? And usually they have no idea. But then I'll say, hey, I went down to the bike rack and I got this. So someone just had it laying around on their bike and I just took it right off. But this reflector right here is a whole bunch of corner reflectors, right? In fact, if I take this guy apart, you can actually feel in there, and there's a whole bunch of little corners in there. So what happens is, the light from the car will come out, hit the corner reflector, it'll bounce, bounce, bounce in there, and it'll come right back to the driver, right? And so it doesn't matter what angle you're at, the light's always going to hit that and then come right back to the car, which is pretty convenient because you want to be able to see them. A lot of shoes now are having little corner reflectors impregnated into the shoe, so that you see a runner. A lot of jackets will have that corner. It's kind of corner reflector-esque material put onto it. An extra credit that we give our students is we have them take pictures of stop signs and other signs. And if you go outside at night with a flash and take a picture of a sign, it visually yells at you. Look at that one there. So the flash hits the sign and it just whacks back at it. And there's another one.
And on the CD, we've got a few that were just emailed from students. Just so if you're going to show your students and you don't have the actual pictures, we've got, I think, about 6 of them. Even in the distance, you can see how many little ones. Now that might be like a car. I don't know if the lights are on, or sometimes cars have little reflectors on their tail lights. And you can see the tree here a little bit. You can see that, but look at all of the signs that just show up everywhere. I mean, you can see them down the block. You'll see the sign light up. And that one's on fire. I mean, that's the nuclear stop sign. This is what stop signs are made out of. Okay, and we got this from 3M, and we're sorry that we just didn't have time to contact them for today's workshop. But they sent us a free packet of this film. And here's the phone number if you want to write this down. It's easy. So 1-800-3M-HELPS. 3M HELPS.
And they're asking for?
Well, they have some basically free material of 3M Scotch-Light is the name of it. And it's just the film that they use on the stop signs or street signs. And it's really, really thin. And to show how it works, just get yourself a laser pointer, as we've done. And now this, you could probably spend a little more time making a mask for the laser pointer.
In the phone number call?
1-800-3M-HELPS.
Yeah.
Already did that, yeah. And you'll notice there, you want the lights off for this? Use the other laser pointer too, see how this goes. And notice that I've got the film flat on the table there. I'm shining the laser on the table, and I don't think any of the light is coming back towards me. How about there? Do you see it make the paper glow? Okay, I mean it's coming right back onto the paper right where the laser came from. You'll see a dot on the ceiling there, and that's just because you've got a plastic cover over there which reflects light, just normal reflection. And then you've got this retro reflection. So, oh yeah, we'll do that. So boom, nice. Now do we have? Where's the packet there? From the other.
Yeah.
Because I was going to give them the bonus demo. They also give you a sheet there with colored, and they've got the clear one. Is it coming back? It's actually hitting me, sometimes on the on my shirt. Okay, the clear one. Anything there coming back? No. Okay, I was just sent the red laser onto the blue side.
Right.
So the blue is absorbing it, and then how about onto the yellow? Is it coming back? Yep. Perfectly fine. How about onto the green?
Nothing.
Nothing. So
No,
nice
what
little.
if you do it this way? Shine it in sideways. Shine it in, come over here so they can see the card as well.
So way over here. Okay, how about onto the, is the card glow, is my card glowing with the white?
Yeah.
Yep. Okay. Okay, how about on the blue? Nope. Green?
Not much.
Okay, and we're looking back to the card here. Yellow?
Yeah.
Oh yeah, red?
Yeah.
Yeah, so a little bonus color demo there. And in honor of Scott, though, someone already stole our thunder there. Scott, this is for you. Yeah. If this is not the most dazzling demonstration, and look at that retro reflection there. And what color is that?
A
Blue?
little bit's coming, yeah, it's coming back a little bit.
A little bit, so there's some green in there. How about on the green?
Yeah.
Yellow, sure.
Blue,
Red?
yellow.
Nothing.
Nada. Okay. And look at the color of that red on there. The green on the.
Oh, that's the fluorescence.
Is that what
Yellow.
that is? Good fluorescence? Yeah. All right, so anyway, nice to get those to show the students that there are little tiny corner reflectors in there.
Wow.
Oh yeah, we had to go backwards a little bit here. I forgot to tell you about this. But one of the moon missions there, the astronauts put a bank of corner reflectors.
Oh,
What's that? Apollo 11? Okay. And here's the bank up there, so it's a small picture there. It doesn't quite give you the size.
It's about 1 meter wide by 1 meter
Yeah, it's
wide.
like a suitcase. What's that?
What year was that?
This is
March
March of 1970. And there's a diagram in here. They give you all the information, kind of interesting, about shining a laser to the moon. And let me get this color picture here that seems to have fallen out. I don't have it. Well, the one that shows the path of the laser beam? Here it is, sorry.
It's on the back.
Yeah, no, this diagram's a little hard to see. Here's the Earth, they shine the laser to the moon. Now, nothing's happening here. You're gonna see a couple little lines there. They're just pointing out that there's a retro reflector on the moon. Think about how small that is. And they're aiming a laser from the Earth to the moon, hit this bank. And here's a diagram of the corner reflector. And they use the term retro reflection.
The worst 3D picture ever.
Oh yeah, this is a diagram of how the laser bounces off with these little cutout angles. They like cut pieces of colored paper. I don't know, it's not so great. But then later on, when the moon is in a different position, the Earth is in a different position, do the same thing. Send the laser back. With this, they can find out that the moon is moving away from us. A couple inches a year.
3 centimeters here.
3 centimeters a year, all from that. So the scientists get paid big bucks, and what they do is they shoot the laser, they hit the stopwatch. When it comes back, they stop the stopwatch, distance equals rate times time. They figure out how far the moon is away. Big bucks.
No error either.
No error with that, yeah, but that's why they get paid.
The big bucks.
The big bucks.
They are rocket scientists.
The laser beam spreads out because it has to travel 250,000 miles away. And what
Actually, you're
happens
half million, right?
What's that? Well, but to get there,
Oh,
it
yeah.
spreads out before it hits that corner reflector. It's the diameter of like a mile by the time it gets there. And so little of that light hits that corner reflector, but of course it comes back. But it spreads out a little bit again, but they're able to detect it. So kind of a neat application of the corner reflector.